Good day, my name is Alexander, and today I want to talk about how to learn to use free energy in a greenhouse, how to accumulate it and use it. Since fuel is only getting more expensive, the question of how to learn to accumulate heat for free and use it for your own needs is very acute. Today I will tell you about the main points regarding the accumulation of heat traps for greenhouses. Let's figure out what a heat accumulator is. Secondly, let's translate in numbers how it works, and in the end, I will talk about profitability, its cost, and then you will understand for yourself whether to use it or not. Watch the video to the end if you like it, like, subscribe, and if you have any questions, write in the comments, I will try to answer everything. Where did the idea of using a heat accumulator for a greenhouse come from in general? Let's start with the basics. We have solar energy that hits the earth. On average, the amount of solar energy, if we convert it to kilowatts, ranges from 1.2 kilowatts per hour per square meter per day to 4. That is, from 1 to 4 kilowatts per hour per square meter, we get energy that falls from the sky. 1 kilowatt is the minimum in the winter period, 4 is in the summer period. What is 1? For example, if we have a greenhouse of 100 square meters, we can accumulate 100 kilowatts per hour in this greenhouse. That's why the idea of heat accumulation arose. There are various ways. Let's look at one of the options. Here we have a pipe. A fan. Soil, water, and everything else. When we have a greenhouse, we have a temperature of plus 35 degrees Celsius at the top when the sun comes out, plus 30 here, plus 25 here, and the soil is plus 18 degrees Celsius. That is, the soil is 18, slightly higher than 25, 30, and 35. According to physics, all heat rises up. There we turn on the fan, hot air enters the pipes and starts working or circulating, and then this heat moves, and due to the temperature difference, this heat begins to accumulate in the ground. Let's consider the practical application in the greenhouse directly. We have a greenhouse measuring 6 by 40, which is an area of 240 square meters, and heat accumulators are installed in it. How are they installed? We have garden beds and fans set up in the greenhouse. The air is hotter at the top and cooler near the ground. When the sun shines, the greenhouse heats up, with temperatures reaching 30-35 degrees Celsius at the top, while the soil remains cooler at around 18-20 degrees Celsius. When we activate the heat accumulators, fans circulate the warm air downward, where it passes through the soil and is stored. Let's do some calculations. For a 240 square meter greenhouse, we can store at least 240 kilowatts of thermal energy per day. Assuming our soil beds are 0.5 meters high, 3.4 meters wide, and 38 meters long, we have about 64 cubic meters of soil. Considering the density of Chernozem soil, this equates to about 85 tons of soil. With a specific heat capacity of 1.3, this soil can store approximately 109 megajoules of thermal energy. If we convert this to kilowatts, it's approximately 30 kilowatts of thermal energy. We have a temperature range from 18 to 25 degrees Celsius, which is a 7-degree temperature change. By multiplying by 7, we can calculate the maximum amount of thermal energy that can be accumulated in the soil. This is 210 kilowatts. That's the thermal energy we can accumulate. The amount of thermal energy emitted by sunlight is 240, so almost all thermal energy is accumulated by us. That is, the heat capacity of natural accumulators that we have in the ground is 210 kilowatts. Now, how much thermal energy can we capture? We have 4 fans of 1,350 watts, which is 5,400. And the performance of our fans is 1,350 multiplied by 4, which is 5,400. Let's take 0.9 efficiency, taking into account all losses, which is 4,800. This is the volume of air that is passed through the pipes per hour. Since we have a temperature of 35 degrees Celsius at the top and 18 degrees Celsius at the bottom, let's assume that we capture very infrequently, only 7 degrees, that is, the heat capacity that could be or during the frequency is 4,800 multiplied by 7 degrees and multiplied by 1.185 and multiplied by 1. What is it? 7 degrees is the change in temperature that we capture, 1.185 is the density of air, and 1 is the heat capacity of air. As a result, we get the figure of 11 kilowatts per hour, which is what we accumulate in the ground. The minimum that we can capture in the winter period. 11.5 kilowatts per hour multiplied on average by 10 hours, which is in the winter period, that is, 10 hours of operation during the day, we got 110 kilowatts of thermal energy, which we accumulate in the ground. Some of the energy is also naturally accumulated, and of course, the accumulation of thermal energy directly by solar heat and direct sunlight that heats the ground itself. So we got the numbers, that is, we have 111, this is the minimum, the maximum is about twice as much, it will be about 200 kilowatts, this is the maximum that we can accumulate in mid-April, that is, when the sunny day is 12 hours, that is, about 200 kilowatts of thermal energy we can accumulate. On average, I consider the average value of 150 kilowatts of thermal energy that we accumulate in winter using heat accumulators. We found that this system can accumulate 150 kilowatts per hour of heat energy in a day. What does this mean for a 6x 40 meter greenhouse? Let's look at a few scenarios. First, if the temperature inside the greenhouse is 18 degrees Celsius and it's 0 degrees outside, we lose about 26 kilowatts per hour. So, 150 kilowatts would last us almost 6 hours. This is the first scenario. Secondly, if it's 10 degrees outside, the heat loss of our 6x 40 meter greenhouse would be 43 kilowatts. The greenhouse loses 43 kilowatts per hour, so with 150 kilowatts, we could maintain the temperature for about 4 hours. Thirdly, if it's 25 degrees outside, with a temperature difference of 43 degrees, we'll lose 63 kilowatts per hour. So, at most, this amount of heat would last 2-3 hours. These numbers show how the heat accumulation system works and its capacity. Overall, this system can be used as a heating element for about 8-9 months a year. In summer, it can also cool the greenhouse because the fan operates at night, cooling the soil. This means we can use this cool soil to cool the greenhouse during the day, preventing significant temperature fluctuations. In summary, while the greenhouse can't rely solely on heat accumulators for heating during winter, it can provide a significant boost. For example, on the coldest day, we can accumulate at least 111 kilowatts. However, if it's 25 degrees outside and the sun sets, we'll use up this accumulated heat in about 2 hours. Therefore, we need to restart the boiler, but we have 2 hours of free energy. In spring, when the sun is at its peak, we can accumulate 200 kilowatts of heat. With this heat, for example, in April, we can maintain a constant temperature of 18 degrees Celsius at night, even if it's 0 degrees outside, meaning we can completely do without heating. The greenhouse temperature will gradually drop from 25 to 18 degrees Celsius and stabilize at 18 degrees Celsius by morning, even if it's 0 degrees outside. In this way, we can save about 20 tons of conventional fuel over the entire period. Conventional fuel in our case refers to firewood, where 1 cubic meter of firewood releases 2100 kilowatts of heat energy. So, we can save 20 cubic meters of oak firewood. Whether this is a lot or a little is up to you. For a 240 square meter greenhouse, we save 20 cubic meters of firewood. In September and May, we don't need heating. In April and October, we can almost completely do without heating thanks to heat accumulators alone and the fact that we save on firewood and the labor of a person who would be tending to the fire. Furthermore, we simply save on the energy required to accumulate this heat. Here are the numbers. This system can cost between $1,000 and $2,000 as a turnkey solution, and it will pay for itself within 2 seasons. If you want, you can build this system yourself, or you can order it from our website. You can order it as a complete package with a greenhouse and all equipment. The last point is energy consumption. How much energy do we need for this system to operate? We have 4 fans that consume about 0.8 kilowatts per hour, meaning they will operate for 20 hours a day. There are periods when they may not operate because the automation system is designed to turn off when the ground surface temperature and air temperature reach 25 degrees Celsius. If the ground and air temperatures are the same, there's no point in circulating the air. Therefore, the system operates and accumulates/releases heat for about 80% of the time. It consumes 16-20 kilowatts per day. Multiply this by days, weeks, and months, and you'll get the total electricity consumption. However, even if we assume the system operates 24 hours a day during the winter and consumes 20 kilowatts for accumulation, or even 100 kilowatts, it's still a worthwhile investment. I'm Alexander from Teplitca. If you liked our video, please subscribe, and we'll continue to break down everything so it's clear to everyone. Like, comment, and visit our website. Best regards. Live in harmony with nature and in the rhythm of progress.